Hey everybody, this is a video to go over the 2025 exam. It was the first year for the new style where they're trying to be friendlier, and every question, like the first FRQ here is called mathematical reasoning, and that or mathematical routines, and that will be what they do for every first FRQ. Now this one here, just looking really quick, you could see that there's a cart moving, a mass is dropped on top, and they go together. This is clearly a collision, and it's going to probably ask about momentum and possibly energy. They give you some information about the cart. It's got a mass C, MC, and then the block is 1/5 C. The block collides and sticks to the top and doesn't slide. So it's like an instant stick. All right. First question, on the axis below, sketch the magnitude of the horizontal momentum of the block cart system. Notice I've underlined block cart system because if it was just the cart, there would be a loss of momentum. And if it was just the block, there would be gain in horizontal momentum. But since it's the block cart system, there are no external forces acting on the block cart system, so the momentum must be constant. Hence my horizontal line that I've drawn here. But check out the scoring guide. Scoring guide says, hey, did you draw a horizontal line for either one of those two sections? Either one. It doesn't really matter. And then you get a second one for a continuous horizontal line. So maybe you thought that the momentum dropped. So if you did a horizontal line and a horizontal line lower, you'd still get 1 out of 2 points. Pretty cool. All right. Moving on, derive an expression for the final velocity of the block cart system in terms of these variables given and physical constants, which means G. Stop writing 9.8 crazies. Begin your derivation by writing a fundamental physics principle or equation from the reference sheet. That means write an equation from the reference sheet. That's all it means. Stop being lazy. Stop not writing the whole thing. Find the equation and write it down. You'll probably get a point. This is clearly conservation of momentum. So as you can see, I started with conservation of momentum, subbed in my values, and I got a final velocity of 5 VC over 6. Next question says, derive an expression for the change in kinetic energy. Begin by writing an equation. So I started with delta K. This isn't conservation of energy. This is change in kinetic energy. Change in kinetic energy means, or any change means final minus initial. So that's what I did. I did final minus initial, and I wrote out an expression before subbing my values. And during any collision, you're probably going to lose kinetic energy, so I'm not worried about this negative value. All right, well, let's see how they score this really quick. Did you start with conservation of momentum? Give yourself a point. Did you get the answer? A correct isolated final expression. So yes, did you get the answer? But literally, you got a point for just starting with conservation of momentum. See? Then here, did you start somewhere that has 1/2 mv squared? 1 point can be earned for showing an expression of kinetic energy. Like, did you try this? Give yourself a point. Did you do the correct masses? And did you get a correct answers? This was 3 points here. Okay. Oh, look at that. There we go. Sorry about that. Moving on. Consider the case where the new block is dropped, and this time there's friction, but the block slides a little bit, but it still stays on it. Okay, that's a new question. So again, it's dropped instead of sticking immediately. There's a little bit of a slide between the block and the cart. And is it a cart? Yeah, it's a cart. Sorry, cart and the block. And it slides a little bit, but they still stay stuck together. Indicate whether the x momentum of the new block cart system, notice I'm focusing on block cart, increases, decreases, remain the same during that time. Let me tell you something. It's going to remain the same. Here's my answer. Friction is internal to the block cart system, so no external forces act on the system. I love throwing those phrases out there. I threw out both of them, that it's internal and no external forces act on the system. And then I said the force of friction of the cart on the block is equal and opposite to the force of friction of the block on the cart. So basically they cancel each other out. I don't know how I did with the scoring guide. Let's take a look. 1 point for indicating it remains constant. Good. By the way, if you did the graph right, it's going to remain constant. One of the following. Did you say the friction force of the new block is equal in magnitude? Oh, yeah. What I said about the block on cart on block, the friction force is equal in magnitude. Did you say that? Did you say the friction force is internal? Did you say no external force, or the net external force is 0? The friction force does not cause net, like all these things, any of those things. Now, somebody came to me recently and said, well, I said the right thing. And I was like, right, but you said 5 wrong things. You can't just throw something at the wall and say, hey, look, I was wrong 5 times, but the 6th guess was good. They're not going to allow that, okay? They're not. For indicating one of the following, the change in momentum of the new block is equal in magnitude, opposite in direction of the change of the cart. I didn't say that. That the impulse exerted, I didn't say that. The correct relationship between the change in momentum of the block cart system and the net external force. Did I say that if there's no external force, that should be no change in momentum? I don't know if I said that clearly enough. Maybe I don't give myself this point. And I should know better to say if there's no external forces, therefore there is no change in momentum, but I'm kind of indicating it with my guess. Maybe I should have been more specific, but what do they say? The momentum of the new block cart system will remain constant because the frictional force exerted is internal to the system, and a net external force will cause a change. Only a net external force will cause a change in momentum. Isn't that like saying, I don't know, no change in momentum if there's no external force? So I don't know if I give myself that point. Whatever. I'm still going to get a 5. I'm going to crush this. Next question. Ooh, this looks intimidating. Springs, inclines, masses. I'm guessing energy. You know why? Because there's a spring. Most often, springs are energy. I see distances. One thing you'll notice here is that the block starts at 0, and there's a 12D marked here. There's a 6D and a 10D. Okay, but either way, the length of from here to the 12D is 12D. Everything's measured from 0. Cool. Some words. Okay. The gravitational potential energy of the block spring Earth system. Block spring Earth system. If Earth is part of the system, there is gravitational potential energy. If Earth is not part of the system, there is no gravitational potential energy. It does work. All right. Either way, check this out. They gave us a bar chart here on the right. And I'm looking, you can see my numbers here. At 10D, which is the location right here, the block is moving. It's still above 0, and the spring is starting to compress. So it says the kinetic energy is 7 EO, E sub E naught. The potential due to gravity is 2, and the spring is 3. Add those together, there's 12. Since there are no external forces acting on the system, as defined, block spring Earth, and there's no, there's no friction, you should have 12 units of energy all the time. That's a huge thing. If you didn't pick up on that, okay, but you got to know that energy is conserved. And so at 0, it's not moving, but it has gravitational potential energy. Look, 12 units of it. Yes, they're going to grade it like that. This is a little trick here, though. This is 12, and it says that the block comes to rest at 12. I'm looking at it right here where it says that. So as a result, 6 is halfway down, meaning I've lost half my potential energy. So I have 6 units of gravitational potential, which means I have to have 6 units of kinetic to conserve energy. We have not hit the spring yet. So scoring guide is probably going to say, like, good job. For one bar that shows only gravitational potential energy, the correct height of the bar is not required to earn this point. Wow. Did you just draw a bar for gravitational potential energy, but you didn't draw it to 12? They love you anyway. Take a point. Did you draw... oh my God, this is so sad. Did you draw a bar for kinetic and a bar for potential due to gravity? The correct heights of the bar are not required. Good job. So if you just drew 2 bars, it doesn't matter. Then the final jars, yeah. This last point you earned for actually adding up to 12. So amazing. You can earn 2 out of 3 for just identifying energies. Good job. You did good. Okay, let's move on. So this, by the way, is question 2, which is called multiple representations. So far we've done a bar chart to represent this scenario. Now, sorry, I didn't have a lot of room on here, so I just kind of squeezed it in. Question B says, starting with conservation of energy. I do not understand after grading some of the FRQs why you don't write that. You're like, nah, I'm going to try my own thing. I'm going to do F equals MA. I like inclines. I don't know what you're doing. They're literally telling you what to start with and giving you a point. It says derive an expression for the spring constant in terms of variables provided. So we're starting at 0 and ending at 12D. So we start with potential, end with spring. That's it. We're at rest at 12D. Admittedly, I did not get this perfect. I did right. So I did my work energy theorem. I'm going to probably get a point for that. I have mgh equals 1/2 kx squared. I had originally mg, the height would be 12d sine theta. We don't know what theta is. That's fine. And then I did 1/2 kx squared. So my answer originally had x squared. X, however, originally the spring is at 8d and it compresses to 12d, so it compresses a distance 4d. You needed to sub that in for x, and you can see I did it, but originally I did not. All right, so I'm not perfect, but I'm good with that. All right, did you start with conservation of energy? Yeah, give yourself a point. This is what I'm saying. Like, I don't understand why some people are like, do I really need to? You're giving away the easy points. For equating gravitational to spring, did you write mgh equals 1/2 kx squared? That's another point. That's amazing. All you have to do is the basic stuff. Stop being lazy, find the equation on the equation sheet, and write it down. Most of you do an amazing job, but some people are like, do I have to? I don't get that. Yes, you have to. Question answered. For one of the following, did you substitute 12d sine theta for delta y? Or did you do 4d for delta x? Now here, I would have earned the point because I did the 12d, but I just left it as x because I'm stupid. For a correct expression for k, I would have lost that point because I did not have a correct expression, but just because I wrote conservation of energy the right way, and I started with potential and ended with kinetic, and I said 12d, I just got 3 out of 4 points. That's 75% of the derivation. That's a 5. Alrighty then. So there's your correct answer. You can do this one on your own. Sketch and label. Crazies. Some of you didn't label in some of the practice that we've done. You need, if it says label, it's actually bold. Bold means better do it. Sketch means plot points. All right. Sketch a line or curve that represents the total mechanical energy from 8D to 12D. So that's from when we hit the spring until we come to a stop. Okay. Are there any external forces on this system? That's been defined as, again, block, spring, earth. No, there are no external forces. So what do you know about the total mechanical energy? They said E. I wrote TME for the block, spring, earth system. Well, it's constant. It's always 12. Okay. In the end, you can see here that they've already graphed spring energy. It goes up to 12. That's the last form of energy. There's nothing else except spring energy, and it's at 12. So 12 is what it must be the entire time. All right. Notice I wrote TME, a little arrow, so they know which one I'm talking about. And no, I didn't use a straight edge. I know it's because I didn't have one on me at the time. But then I got one for the next one. I got straight edge for this, for the potential. Then it says sketch and label the gravitational potential energy. Remember, 12 is the most, and if we're at 8D to start, that means final height is 0. At 12D, we're at a height of 4D, which means I have 4 energy units for potential energy, and it goes to 0 at the end. Now, you may have wanted to do a curve, but potential energy is mgh, and we're basing it on h, so it is linear. So there's your graph, okay? Notice I've labeled with an arrow. How do we get for points on this one? Let's see. For sketching a horizontal line that is continuous. Cool. For sketching a line that is decreasing with labels. Oh, it just says sketching a line that is decreasing with a label that indicates gravitational potential energy. So did you draw something that goes down? Give yourself a point. All right. But then did you draw it correctly? For a star line that represents gravitational potential energy, like, did you draw it correctly? So again, it's 2 out of 3 points you should be getting. Even if you drew a curve, it's okay, but you didn't do it correctly. Notice they are labeled. There you go. Now, this question was tricky, even for me coming up here. Oh, hold on. It's right. Oh, is it missing? Did I not scan it? I didn't scan it. Holy shnikes. Oh, This video is bad now. All right, but let's take a look at the question then. Okay, the question was, sorry, but I'm not redoing this video. All right, the question was, where is there more kinetic energy? When you're at 8D or 9D. And it said you must refer to the graph. Okay? So we're talking about graph. We're not talking about math. It said you had to go back to the graph. All right. Well, look here. At 8D, there's 0 spring, 4 potential due to gravity, which means there must be 8 kinetic, right? They have to add up to 12. At 9, there's 3 gravitational potential and a little less than 1 of the spring. This adds up to a little less than 4, meaning there's a little more than 8 units of kinetic energy. So you actually have more kinetic energy at 9D after hitting the spring. Now, check this out. They don't care if that's correct. What they do care about is, does your answer match? So let's say you were insane and you drew like your potential energy from 10 to 0. Okay. I mean, as long as your words are going to match your graph, you will get points. That's what this whole thing here is. So as long as your thing matches, you get points. Like if you drew potential energy as constant the whole time, like and answered correctly, you're good. So here is what I kind of said. But just realize if you're consistent, even though your graph is wrong and you're consistent, you're still going to get points. So there we go. All right. I'm sorry I didn't scan that. All right. Number 3 is experimental design. All right. This was last year. There was sorry, I wrote all over this because there wasn't a lot of room to write, but basically it was a lever. It was like a meter stick that was pivoted in the middle, and you had a spring scale attached to the end and an unknown mass that you can hang everywhere. And you're asked to take measurements that will allow students to create a linear graph whose slope can be used to determine the mass of the unknown block. All right. Describe an experimental procedure that we could use, blah, 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 blah. Are you going to start with that? Because I didn't. I looked at the next question. It says, describe how we could graph. Like, what are we going to graph? That means do math. So I did B first. All right. Sum of the torques is 0 because this is a rotational equilibrium problem. The easiest possible rotational problem you can get. There's a torque created by the spring scale pulling at this distance and the hanging mass at its distance. That's what I wrote here. Force of scale, distance for spring, our spring, the force of gravity on that mass, MOG, and the distance of the block. All right. I rearranged for that, and I got force of spring, distance of spring over G, distance block. It tells me everything I need to do. So now I go back to my procedure. Hang a block at one of the holes and measure distance from hole to pivot point with a meter stick. I wasn't sure if I had to say this because it is a meter stick. I don't know, but I said it anyway. Measure the distance from the spring scale to the pivot using the meter stick. This is fixed. The spring scale is fixed. It's always a 0.5 centimeter, but I'm going to say measure anyway. Use the spring scale to keep the system horizontal. I didn't know if I needed to say that, but it's not wrong. And measure the force on the spring scale. Repeat the procedure multiple times to minimize uncertainty. I wonder if there's anything I might be able to vary. Sorry, I'm being sarcastic. You know that. Yeah, you could vary the distance that you hang the mass to the pivot point. So say it. Varying the position of the block on the meter stick. Yeah. All right. What do I want to graph? I said that this is what I'm going to graph. Check this. You saw my derivation. Graph the product of the spring force and the distance of the spring to the pivot. And I wrote it in parentheses, Fs times R on the y-axis, and the distance of the block to the pivot times G, which is RBG on the x-axis. But you have to say how it will be used. Note how the data collected will be graphed and how that graph could be analyzed. So I'm specifically saying the slope of this graph will be the mass of the block. All right, check this out. What if, for example, you said, I want to graph the force of the spring on the y-axis and the distance of the block to the pivot point on the y-axis. Cool. So I'm just doing Fs over Rb. Totally fine. All right. I would say graph those two things, get the slope, and then multiply by the distance of the spring scale to the pivot point and divide by g, and that will be the mass of the block. You have many combinations here. You can do a lot. You could have done Fs over GRB, and then the slope would be Fs over GRB. Get the slope and multiply by distance of the spring to the pivot point. Like, all these things are totally fine. Like, check out their scoring guide. This is amazing. Okay, first of all, as per usual, did you write a procedure that kind of makes sense? Good. Did you say repeat multiple times? That's what I'm saying. If you don't say this, I can't help you anymore. Like, I don't know what to do. Just say it. You didn't have to say vary, but they said repeat multiple times for one location, or collect force measurements for multiple locations. Say them both. All right, so you can see the procedure here. Attach the block and measure the distance. I would say using a meter stick. Record the reading from the scale when the meter stick is horizontal. So they did say that as well. Repeat the data collection and attaching the block to different things, different holes, repeat it multiple times. Basically, very straightforward. Last year's test was so amazingly easy. What to graph? Check this out. Where's the scoring guide for this? It's crazy. You could graph so many different things. Any response that correctly identifies the functional dependence, the point can be earned for this. So basically, all those things I went through, force is a function of distance to, like, look at all these. These are all these options. Force is a function of g times distance. I said that one. Force, like any of these, you can get credit. But then here's the thing. I don't know where mine is. This was mine. Force as a function of g times the ratio of the distance. That's basically what I said. Notice they said the slope is mass. You actually have to say this. So column 1 is what you can graph, get a point. Column 2 here, the analysis, is how you can use that graph to get the value you need. Like, basically, is it the slope? Is it the slope times something? All right. Okay. Indicate whether the speed of the block. Oh, this is in the wrong place. Fascinating. This is the one that I said before. Indicate the speed of the block. By the way, sorry, this is so out of order, but whatevs. I wasn't sure, to be honest. This is going back to the springy thingy. I was like, but it hit the spring. Wouldn't it slow it down, or is it going faster because it went down? I read this next question. Justify your response with the... And then I was like, oh, it said, look at the graph and justify your answer based on the graph. And I was like, oh, okay, that's a good idea. And that's how I answered this question, because originally I was just thinking, because I stopped here. Read. Keep reading. All right. Next question. Whoo, boy, that looks different. Okay, they've adjusted the setup. I'm not going to get into it. You can see it. Students correctly determine the relationship is this. Wow. Some of the ones that you've done for practice were way harder than this. And you want to graph something so that you can get the mass again. What did I do? I rearranged for mass. I just rearranged this expression for mass. And they said graph 1 over sine theta on the x. All right. You know what I put it on the y? 6ft over 5g. Doing that whole thing. All right. Once I decided that, and again, first thing I did was rearrange the math for the thing that I want. Okay. I went back up to my chart. I did 6ft, 5g, 1 over sine theta. I put all these things in my chart so I knew what to plot. All right. Clearly label the vertical axis, including units. Units would be kilograms. It's actually not too bad to think about. We're trying to get mass, and 1 over sine theta has no units, but also newtons over meters per second squared becomes a kilogram. All right. Now, for me, check this out. This was interesting. 2.57. If I treated each of these as 0.5, I would end up with 2.5 at the top here. And then what am I going to do about 2.57? You do not graph outside the grid. You don't draw another line. You will lose points for doing this. Just rescale it. So I scaled it where every 4 lines was 0.5. I plotted my points. Notice my points are plotted. I have used a ruler for a trend line, and I've circled the points that I'm using. I usually start looking for a point here. Oh, I found one. And then I'll come in from the other side. I'm like, that's close, that's close, that's close, that's close. Ooh, I like that one. This way I know they're far apart. All right, so how do they score this real quick? Dude, look at this. You could graph any of these things. Any of them. Because if you look at the rearranged math, where's my rearranged math? Sorry. Rearranged math. You could have just graphed FT. That's what they gave us. They gave us FT. It would have been a lot easier. And then you would get your slope and multiply it by 6 over 5g. You could have did FT over g, gotten the slope, and multiply it by 6 over 5. You could do any combination you want. All right, so they gave us all the options here. I like to rearrange and get the thing I want. All right, so did you get any of those things? Give yourself a point. Now, more importantly, not more importantly, notice, look at, did you include units on the vertical axis? Did you correctly plot one of the following? Yeah, you did. Just, oh my God. Quantities indicated in part C. Quantities indicated on the x-axis. Wait, you could have plotted the x-axis correct, but not the y? I don't know. Quantities indicated in table 2. They're trying to give you points. Did you draw a best fit line? Okay. So that's 4 points. I don't understand why you can't get at least 3 out of 4 on this. Then the last thing was to draw the best fit line. Using that best fit line, calculate the experimental value. That means do slope. Notice here, I've written the word slope. I don't write M because remember, M is mass. And if you're not solving for mass, you're wrong. So write slope. Turns out my slope is mass. I wrote M equals slope equals that. And their scoring guide. Look at this. They have so many different combinations. Like I did this one. This is what I graphed. And so my slope equals M, or M is, the mass is slope. Other examples, like this one, we said the slope is going to be, well, this is your slope, and then you multiply it by 6/5 over G. And that's how you get the mass. So they're trying to give you points for anything. But you can't just get slope and call it a day. You got to try to use it unless your slope is that value. Okay, last one. This was a gift. There's a swimmer, and he lets the block go. It accelerates up. Cool. What if we change the density of the fluid? What would happen to the acceleration? Justify your answer in terms of all forces, blah, 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 blah. That sounds like fun. Let me read B. Consider the case, blah, 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 blah. Starting with Newton's second law, derive an expression. You know what I'm going to do first? I'm going to derive this expression because it's going to answer my question. I'm not going to try and answer first. And also, second law is the sum of the forces is MA, or F net equals MA. It is not F equals MA. You will not earn that point. F means there's one force when in fact there's more than one. So it's wrong. Write the sum. Don't be like, do I have to? I'm seriously tired of hearing, do I have to? No, you don't. Lose the easiest point because I told you to write something down. You're crazy. All right. I'll get off my high horse, but still. Notice I did B first. You got the buoyant force up, gravity down equals MA. Buoyant is rho VG. And then you're solving for A. This was stupidly easy last year. People came in and were like, oh my God, that was like too easy. I'm worried. No, it was that easy. So we have an expression for A. Now this is helping me. I'm looking here and I'm like, oh, look, if density increases, acceleration increases. Cool. All right. I know that I circled A1 is less than A2. Fine. And I did something I shouldn't have done, but here's my answer for A. Remember, are we comparing scenarios? You better say what's the same, and in both cases, the gravitational force acts down on the block. It is the same. However, increasing the density will increase the buoyant force, acting opposite gravity. Okay? Start saying things like this creates a larger net force. Say the words net force because net force is what leads to acceleration. Throw those phrases in there. Net force, acceleration. A larger net leads to a larger acceleration, leads to a larger velocity, although they're not asking about this. Okay. However, I did circle that A1 is less than A2, so I really should have described this as scenario 1 has less density. And therefore, a greater less of a net force acting on the system and therefore less acceleration. I should have done it that way because I said A1 is less than A2. I went the wrong way, and I know I criticize all of you for doing that, and I'm sorry. All right. C, the easiest question. Number 4, this is called qualitative quantitative, meaning you have to do some qualitative, got to do some quantitative, and you got to compare them. Indicate whether what you said was correct. Hell yeah, it is. You know why? Because they should match. I said, yes, it's consistent because density is in the numerator, and if density increases, acceleration increases since it's also in the numerator. That's it. Stop saying relationships. Don't say direct. There's no such thing as a positive relationship. I hope you have a positive, healthy relationship with somebody in your life as well, but stop saying relationships. It's just say numerator. Just say location. You're going to lose a point if you say it's a squared relationship. No, it's not. So anyway, let's check out the scoring guide and call it a day. All right. Did you indicate that? Did you justify the blocks have the same weight or mass? So there it is. You have to say what's the same. In this case, the force of gravity. Did you say that the salt water exerts a larger buoyant force? Notice this. Or the fresh water exerts a smaller buoyant force. They'll accept either one, which makes me happy because we've been saying one, like we circle one thing and explain the other, but I think they're going to let it go. I'm hoping. So there are identical forces downward. It's submerged, whatever. The buoyant force is proportional to density. They didn't say directly. They just said proportional. That's fine. Don't worry about anything else, I guess. The block and the water, buoyant force. Okay, here. Therefore, larger net force, larger acceleration. All right. It doesn't say you have to say net force and acceleration, but I would not skip that. A multi-step derivation that starts with Newton's second law. Did you write sum of the forces equals ma? No, I didn't think I needed to. Good. That's great. Did you indicate that rho vg is the buoyant force? So all you have to do is write second law, sum of the force equals ma, and substitute in the equation for buoyant force. They're trying to help you. And did you get a correct expression? So that's important. Here, did you attempt to address the functional dependence? Like basically, yes, it agrees because of this, like that. Yeah, it agrees for correctly functional. Okay. Theirs is weird because they talked about the whole fraction here, and they didn't say numerator, denominator. So the acceleration will be larger, the density larger. In my expression, the acceleration increases with density because of the rho vg over m term. This whole thing. I'm like, all right, that sounds a little weird. I guess they'll accept it, but simply say if the density increases since it's in the numerator, acceleration will increase because it's in the numerator. Now, let's say the equation you derived had these things flip-flopped, m over rho vg. Well, this doesn't agree with what I said in part A. All right. That's weird, even though I've been told many times they should agree since they model the same thing. Well, check it out, though. You would say, no, it doesn't agree. Because as density increases, acceleration would decrease because density is in the denominator and acceleration is in the numerator, and you would earn full points for this. Anyway, I hope this video helps. I just want to take you through one more time. Like, do the math when you can. Read ahead. If you have an option to derive. In question 1, when they ask you to, in question 1, or the ones when they ask you to graph, do the graphing first. When they say, like, what would you graph? Like here. Where is it? I'm so sorry. Yeah. Do the graph first. The graph that you end up drawing, remember to label with units, use a straight edge, use at least half the graph, don't go off the graph. Like, these are easy points. When they say start with Bernoulli, you're like, I'm not doing that. I'm going to just write the word Bernoulli and do what I want. No, earn the easy points. I really want you all to do well. I want you to get the easy points and then walk away feeling good. So anyway, I hope this video helped in some way, shape, or form. If it didn't, I'm sorry. I hope you watched it at least time and a half because, damn, this is a long video. 3 out of 5 stars.